Hamilton Choir, folks. They're awesome.
Very cute.
And battery.
Batteries.
Yeah.
Always the batteries.
Well, I had to, hi, if anyone doesn't know me, I'm Kevin from the San Jose City Job Corps. It's been a while since we've been here. We've been kind of busy, you know. I mean, Francisco's been coming here, but wish we could come. Anyway, so, you know, batteries, you always give me the hardest time. This is what being born with big hands, I swear. It's a curse. Anyway, so it's been a while since we've been here, you know, a couple months. And so, as if anyone doesn't know, we have a competition this Friday. And so, I built a robot with some help with a couple other people to code it and stuff and finish building me. And so, this is the end product. If anyone remembers what the robots I brought when we first came here, they looked a lot different. Had more wires and stuff. You know you.
That's what robot's name.
So, let's see. So, we updated this. I call it Bugger because every step of the way, just like now, it's giving me a hard time. So, we had a code to where we added this claw, so it goes up, goes down, then we have closing, opening. And it's still a work in progress like all robots are, you know. So, as you'll be able to see, I'm to pick up that water bottle for my competition. It is really fast. Okay. Oh, wrong one. There we go. I need more way in the back. See? Let's see what happens when I do this. Well, live and learn. I mean, I just got done today. I guess not, you know. Okay, let's see if I do this. Apparently, no.
Close. Drink some of it.
Oh, there we go. Let's try this.
Oh, I see. You're going for phase 2.
Oh, phase 4 coming.
Come
You let
on.
go of it now, it'll drop.
Yay! I did it!
Hey, Kevin, on your event Friday, do you have to use a water bottle or can you use a block?
It could either one.
Oh, I would prefer a block because that water bottle just picked my robot up. That tells you something. A water bottle weighs more than that.
Put light water.
Light water, sure. I'll put on some sparkling water so it floats.
Just drink some water.
Drink it. You know what? Chugging time.
Well, no.
Chug.
That's radio control, though.
Yeah.
Right? Okay.
So, I mean, this robot was designed to be.
Not judging, not judging.
Yeah. That's why it's called Bugger because the other two robots worked fine when it sensed areas. Mine decided, even though it was 100% exactly like the others, to say, no, I'm going to do that. So this is the end result. Oops. And you're about to see why that turn is deadly.
Nice.
Let's see if I can do this.
Hey!
Yay! Yay, half a bottle. So, thank you again. If there's any more question about the competition, come to me or Francisco over there. If you want to come, it's from Friday at 2 o'clock till 6 o'clock at the San Jose Job Corps Center over in East Hills.
Yeah, and it's a free entrance, so anybody who wants to be a part of it, you can. I'll be putting the Eventbrite link on it. It's free, your free tickets, and I'll put it on the mailing list, so you guys will be able to get it from there. So we're having 4 challenges. It's kind of simple, and we did something similar to the Robo game. So it's the tabletop. We're doing the Walker challenge, the balancer, and the line following robot. Yeah, challenge. So if you already have a robot made that will that can compete in one of those competitions and you still want to sign up, just let me know and I'll get you in there. Yeah.
Well, thank you for all your time. It was a wonderful audience.
I'm Paul, that's Gertz.
Talk louder.
That's Fast. We're Team Fast Pick. We have a third person on the team, Simon Chu. We are competing in the JD Robotics picking competition in China. Last time we were here, we showed the robot. It did less than it's going to do tonight. And at that time, we didn't know if we were selected or not. So we were selected. And so we... So they had 100 teams in China competing for 8 slots, and then they had 2 international slots. So we're one of the 2, and then a team out of Singapore that actually looks really good. So, So a couple of things that we've got. We've got the robot here. We also have an apparatus set up with multiple cameras so we can take pictures of the objects that we're supposed to pick, because it's a picking competition for a mobile robot like at a store where you have to pick up various products. So we have to machine learn on those products, and the products are Chinese. And so about half of them are food, and we can't get those products here. We've been to Ranch 99 everywhere else. And they can't ship them to us because about half of them have food. And so what they did was they took all the packaging, took the contents out, and sent us flat packaging. We have to rehydrate them, and then do machine learning on those, and then go back and work around that. So we have to get the weights dialed in and stuff. So those are 2 pieces of hardware that we've got cooked up to automate the machine learning product capture side, and then execute on it. So I think the new thing that you're going to see here today has the object recognition in it based on the Intel RealSense viewing the object, but the learning was actually done on Raspberry Pi cameras. So it's based on YOLO 3. So.
I just want to say the HBRC has the baddest podium in the land.
Talk about YOLO.
YOLO. You only look once. Anybody not know what YOLO is? There's a good TED Talk on YOLO. If the challenge in robotics is we don't know what things are, and machine learning allows us to look at things and recognize what they are, and YOLO does that in one neural network. It recognizes all types of objects, so it's incredibly fast. So if I put a YOLO looking at you guys, every person would have a little bounding box around them and some other things, and you'll see that in here. So we take YOLO out of the box, YOLO 3, and then we add stuff to the training. And so that's an ongoing thing. We looked at YOLO, single shot detectors. That was the one that we thought we were going to use because they have higher accuracy. YOLO turned out is working well for us right now. I'm not the guru on that. We run the image recognition on a NVIDIA TX2. Right now the TX2 is on the floor. We got a little tiny box for the TX2. So we basically have a cool, what is it called? I can't remember the name of the box, but it's an impressive little packaging for the NVIDIA card. We're using the Intel D435s, which are kind of near field depth sensors. And that works for us because we don't need to see particularly far. But what that does is anything that's within about 1 meter or so, we have every point on it is accurate to within less than 1 millimeter. So when we see an object, we know exactly where it is, and you'll see that because we reach out to it, stop right in front of it before we grab it. So it's pretty easy.
Is it DX35?
D435. The robot breaks down into 3 pieces, still has a large case to travel, and when we go back and forth to China, Mike, you might know this, but I think this is going to cost $3,000, $4,000, $5,000, $6,000 round trip for the robot itself. It's easier than we are, or it's harder than we are. Pretty fun to watch. Good demo, huh? So,
Talk louder, Gertz.
Okay. I won't be showing any grasping today because I don't know what that code is doing right now. But we need this new code that is recognizing objects. So we'll see if that works.
so we're not grasping today?
Good.
Now,
Turn the camera down and we're going to show you something on the screen.
I will show the screen. And maybe this one as well. I can get to that side. No. Okay, anyway, all that we can see here is that this is a depth image from the RealSense 3D camera. This purple area, it detects as the surface of the table, and the red thing is the object on the table, and we are running yellow detection on the NVIDIA board here, which is giving up as the detections, and it is telling us that it is a bottle, and we are matching that with the 3D input, and here it is actually saying that it is a bottle. And if we look at the numbers here, we don't see which is which. Okay, it is telling us that it is 30 centimeters from the camera, which would be important if we would try to grasp it. And it is telling us that it is 5 centimeters wide and 11 centimeters from the center of the camera. So that's another of the important pieces that we need to actually do this challenge. Let's see if I have another image here for the yellow detection. So let's swap the images. So this is output from YOLO. So we see that there is a bottle, there is a person on the other end, there's a chair.
Can you move away from closer? It's only 50% sure it's a person.
Lots of chairs.
Doesn't understand microphones.
Yeah.
It only knows 80 objects, so we will need to add all of our objects that we will need to detect. So we will have some 20, I think.
Something like that. And we get a pick list out of that. So we essentially have a shopping list and we have to go find it amongst all the items there.
Apple? Yeah, an apple.
Can you do it upside down?
That was a good question, actually. It's kind of fun. We can turn the apple upside down, too.
Your bottle is gone.
No, that's not a button.
What is the bottle?
More training.
So when we're doing the training, we do actually, we train the single object, we put multiple objects on for occlusions, we lay them down on their side. This has not been through that. Clearly. Apple upside down.
But the probability's low.
And this actually is the pre-trained data set, so we will need actually do all our training. Still, we have to do.
Yep.
How long does it take to train it for something?
So there's multiple steps in it. The first step is you have to take over 1,000 pictures of each object. And so what we do is we have a rotating table that allows us to do that. We have multiple angles on it simultaneously. And then those can be post-manipulated to do certain things. Then they need to have a bounding box around them. So we put them through machine learning to get a bounding box. And then we check all those bounding boxes. Because having the quality data for training is important, but we use automated tools to come up with the bounding box. So we have to check that. And then we have to label them, and we have a way to do that automatically when we capture the whole data set. So all the hierarchies have the right labels when we automatically capture it. And then that goes into training. And the training's actually, what was he doing? About, it wasn't a terribly long amount of time for each one. It was fairly fast. I mean, it was on the order of, within hours we can train on our data set if we have all the data. With the right, but we have to have the right compute for that. Yeah.
So does it only check the form of the bottle, or does it look at the label and all that stuff?
It looks at all the identifying marks there. So for example, one of the things that we're overlaying on this is that we're also going to do language understanding on it. So we're going to do Chinese so that we recognize what the labels are saying. So we're getting things like a particular Coca-Cola. We have to identify that from something else. And one of the things that YOLO does is it will come up with statistics, but it will have, you know, it's a can, pi, and then you have to deal with subgroups of that, so train around that. So we're using some language stuff, just trying a variety of tricks
So
that we
it
have
does
some
form
verification.
first and then details, or what?
It's different trainings. Yeah. Yes.
What's that black tarp thing on the front of your robot?
This right here?
The belt, yeah.
So you can't see the grippers working. It's two grippers, one above the other, and they have a full tarp between it. So when they pick up, they kind of like wrap it with a cape and hold on to it. And it's real grippy. So anything that gets in there basically doesn't fall out, even if it's kind of partially in there. Yeah.
I just looked up the price on the RealSense camera, and $190 is the low one, but then there's a $927 one.
I didn't do that one.
And then there's a $5,409.
I can't even see those other ones.
I think I see a price for $179.
I
Yeah.
don't understand why they're so ridiculous.
Maybe you already said it, but when is the competition in China?
So it's December 19th. They fly us out there. They're doing everything, and I think we'll get there at least 3 days ahead, just because they give us some new items there that we have to train on. So we have plenty of time there. It'll be interesting. Yeah.
What's the grand prize for this competition?
So the top winning on it's about $70,000. So it's nice.
Are the grippers 3D printed?
They are. Yeah.
So the data feed that from the camera right now, is this from the RealSense 3D camera, or is this from what we're looking at right now? Is this from the 3D camera?
Yeah, that is from 3D camera. It has actually three cameras on it. And so this one is from RGB camera, and it has the drivers to actually align the color image with the depth image.
So I'm familiar with using 3D cameras for mapping, but what could you talk about the technical advantages of using a 3D camera for this kind of computer vision?
Well,
Specifically robots.
what it enables us to do is to know where the object is. So we know how far to extend the arm, and Actually, another advantage is that this YOLO thing is not extremely fast. So if we want to actually drive along the shelf and stop at the object, so if we only get a recognition, say, 3 times a second, that's not nearly enough to actually drive by. But 3D processing is fast. We can do it in real time, and it is easy to see what the object is. It's just we don't know what it is. And then we can ask YOLO, what is it that we're seeing?
So using a 3D camera provides faster data recognition than a standard.
Well, it provides the data to use to actually operate in this 3D world. YOLO is only providing us knowledge about what that object is, but everything else we do by 3D.
Yeah, the key thing on the depth sensor that we have to have is the depth, because we actually reach out to grab it.
So how many frames a second of depth are you getting?
15 at this point we're using.
You can go higher though. The RealSense camera's got an onboard ASIC, so does all the depth.
Yes, but we have some limits of processing that stuff that comes out of the camera.
Okay. Are you running it in USB 2 mode or USB 2?
No, the USB itself is fine. It is coming out on USB 3, but we are using right now this Intel NUC processing unit. And the stuff that we are doing right now is it takes about 50% of the one thread that we are running on. So there is not much more compute power to process this 3D stuff.
There's one back here.
If y'all win, what would y'all like to use the prize money for?
Ferrari.
A Ferrari? Okay.
What? How much power does this consume?
The most, just like an electric car. The number one thing is the wheels. The Tegra 2 that we're putting on is 15 watts. I don't know what the NUC is. Everything else pretty marginal on there. The wheels consume it all.
The bounding boxes were overly tall.
Poor training.
So that you'll train it out so they're cropped right on the object?
They're supposed to be cropped on the object. So if I do this, it should hit my actual bounding box.
Okay.
Real quick, does anybody else have a run what you run robot? Okay, cool. Then we will wrap up.
Yeah.
Yep. More stuff to. All right. No. I mean, they're gonna wrap up so that we can move on to the other people. So raise your hand if you have a run what you brung.
Over there.
Yes. Okay. Come on up. Cool. That was Kurt and Paul. Very cool.